Faro Airport is the only international airport in the Algarve region, in the south of Portugal. Located 7 kilometers away from Faro, the capital city of the Algarve region, Faro Airport handled 7.7 million passengers in 2016, mainly tourists exploring the nice weather, food, beaches and golf courses that the Algarve can offer. The airport terminal is the main building of Faro Airport, where both passengers' departures and arrivals are processed. It has a footprint area of about 49,000 square meters, with 5 main floors and 2 technical floors, with a total capacity of 6,000 passengers per hour, 3,000 on departures and 3,000 on arrivals. The terminal has several different activities. The operations, services, handling, security and safety, maintenance, administrative services, restaurants, shopping, and finally, transportation. As for technical equipment to handle the whole operation, Faro Airport has several infrastructures, such as 6 electrical substations, 2 baggage handling systems, a pressurized water supply system, and the HVAC system, with 2 thermal plants. The total electricity consumption of Faro Airport in 2016 was 14.5 gigawatt-hour. To control and monitor the correct and efficient functioning of the equipment, Faro Airport has several systems, such as the building management system that controls the HVAC, the lighting, the transformer substations, the electrical boards, the mechanical equipment, the water supply, the airfield ground lighting and the medium voltage grid, the inside air quality system, the energy and water measuring system, the maintenance management system, the flight information and planning system, and finally, the access control system. Despite having 2 maintenance technicians 24/7, these men execute several corrective and preventive tasks, and there is no one exclusively dedicated to be looking at those monitoring systems, check for failures and make the necessary adjustments to optimize their energy consumption. Energy in Time is a European project that started in October of 2013 with the objective of fulfilling this need and delivering it in a 48 months period. The main financing of this project is provided by the European Union with €5.1 million, which represents a 66% contribution of the total cost, which is €7.7 million. With 13 partners from 8 countries from all over Europe, this project aimed for the development of an integrated control and operation tool, which would be automatically and remotely operated, to be implemented in all the building energy management systems available, linking and connecting all of them through their outputs. 3 of the partners are demo sites, where the system would be implemented and tested. Each demo site is representing a type of building and its use, with different typologies and in different climate areas. ANA, with Faro Airport, representing a passenger terminal building, Kaverian, with a commercial and office building in Helsinki, and a hotel in Levi. ICPE, with a laboratory and office building in Bucharest. The whole work was divided in 9 different work packages and with a well-distributed framework that included links between all the partners. All the partners reunited after every 6 months of working on the project, to discuss the status of every work package and to align strategies to best suit the project needs. There were meetings in Madrid, in Spain, Faro, in Portugal, Helsinki, in Finland, Brussels, in Belgium, Bucharest, in Romania, Barcelona, in Spain, Levi, in Finland, and Cork, in Ireland. After months of work, there was finally a centralized remote control, the CRC, ready to operate and start testing in a real scenario situation. With basis on the equipment status, on the boarding room's existing air quality conditions, and on the required set points, and depending on the weather forecast, on the thermal behavior simulation model, and on the boarding room occupancy, this CRC will process all these data, and act over the equipment, freeing the technicians for other tasks. For example, an empty boarding room with no expected occupancy will have the lights and the HVAC system shut down. Moments before this boarding room is expected to be occupied, the HVAC system will be turned on automatically so the boarding room delivers the required air quality when the passengers arrive. At the same time, the lights will turn on. During the use of the boarding room, the equipment will keep working, so all the passengers arriving and departing can enjoy their short stay in this boarding room. The system is constantly learning and optimizing the decisions based on experience. For example, considering the outside temperature, expected occupancy and room temperature, the system decides how much time it takes for the air conditioning to cool down the boarding gate. Every time that calculation is made, the system gets more and more precise. When the boarding room is no longer being used and the room is empty, the flight information and planning system will send that information to the CRC. In that precise moment, the CRC will shut down the equipment, so the energy is not wasted unnecessarily. The project integrates also other modules, such as the Model On-Demand Control, the Fault Adaptive Control, the Continuous Commissioning, the Predictive Maintenance, the Fault Detection and Diagnostics, and the Decision Support Tool. Not all of these modules were applied in Faro Airport. However, they were successfully implemented and tested at the other demo sites. As for the end results of the project, there were some improvements in the HVAC operation of Faro Airport, as a 6% thermal savings and a 3% electrical savings were measured. As for the other demo sites, Energy in Time achieved the following thermal energy savings: 26% in Cinematalo Building, 2% in Panorama Hotel, and 11% in ICPE Building. In Faro Airport, the demonstration period took place during the warmest and busiest season of the year, which means that the equipment and the facilities were operating continuously throughout the day, and almost with no interruptions. The timing was not the best, as the energy savings would be much larger during spring and autumn. Simulations calculated 15% of energy savings during these intermediate seasons. The Energy in Time partners believe that the project is a great contribution to energy efficiency savings in non-residential buildings. The project is now finalized, but the journey for building energy efficiency continues to all of us, aiming for a better and more sustainable planet. Having reached the end of this project and having achieved the proposed objectives, we believe that final solution can be applied in other non-residential buildings as well as in the other Portuguese airports managed by ANA and even other airports managed by VINCI Airports, all over the world.